Hello everyone, my name is Abhinav and we are a group of 5 members doing a project called Automated Library Shelving System. So I'm going to discuss the problem statement. The current automated library shelving system faces a significant challenge due to its reliance on microcontrollers. So these microcontrollers are unsuitable for handling the substantial motor load required to move the cells, leading to frequent short circuits and rendering the system to be ineffective. So to address this issue, we proposed our project Automated Library Shelving System. So this innovative solution has been carefully engineered to automate shelf movement and to enhance the safety through obstacle detection and enable individual self-control using the programmable logic controllers and the human-machine interface. So the backbone of our project consists of PLCs which seamlessly orchestrate the movement of the library cells along the predetermined tracks. This centralized control ensures precise and efficient operation, so by minimizing the risk of errors and malfunctions of the system. Now my teammate will take over.
Hi, I'm Shashank Reddy. In our advanced PLC project, we have utilized several components. To begin with, we have employed a rack and pinion mechanism for the movement of our cabinets, which were designed using our 3D printing module. The key components used in our project include NEMA stepper motor for cabinet movement, motor drivers for stepper motor control, and Allen-Bradley Compact Logic's L32E for sending control signals to the motor. We also used AC to DC converter, photoelectric sensors, and limit switches. These components work together to ensure smooth and safe operation of the system. Firstly, the photoelectric sensor acts as a safety measure. If the laser beam is interrupted at any point, the sensor immediately stops the system to prevent accidents. Additionally, limit switches were positioned at the first and fourth cabinet to monitor their position and movement, providing important feedback to the control system. The cabinets are driven by stepper motors, which offer precise control over their movement. The motors are managed by stepper motor controls that translate control signals into an appropriate electrical pulses. At the core of the system is the Allen-Bradley Compact Logic's L32E PLC, which sends input and output signals to coordinate the actions of all components, ensuring seamless operation. Finally, an AC to DC converter steps down the 110 volt supply to 24 VDC, providing the necessary power for the system's components.
Hello everyone, this is Saikiran. We have developed a HMI screen using the FactoryTalk IO. We have developed for the 4 different shelves in that, and in each shelf we have light, right, left, stop and LED indicator. The LED indicator which shows the photoelectric sensor indication. Whenever the obstacle gets detected by the sensor or triggers, it immediately gives that the sensor is triggered. And also the left and right buttons are used respectively for moving the cabinet left or right, and stop button is used for making it stop, because if there is enough space between the 2 cabinets, we can use the stop button and it maintained until the person again presses the stop button. And if he want to use the different shelves, like as we have said, there are 4 different cabinets. If he want to use the different shelf, he can go back into the main menu and he can select the shelf accordingly and enter into it and use in the same process as I have explained.
I'm Bhargav. I'm going to explain the ladder logic which we have used in this advanced PLC project, automated library shelving system. Initially, in the first rung, we have placed the HMI tags which were used to control through HMI, and this is the second rung which we have used the add-on instruction where we have the stepper pulse output, direction pulse output, which comes from the motor driver which we have used, so that when the values be energized into these outputs, then only the signals will be passed to the motor driver and let the motor be energized. And let me go through the program tags which we have used. These are the outputs which we have used in this program: limit switch and the inputs for respective motors to move forward or in the reverse direction. And every cabinet have their own motor which is enabled by a stepper enable tag. And let me explain you the working. Initially in the third rung, we have placed the motor 1's input. Whenever we toggle this one, it goes through it and energize the HMI jog forward output, which is connected to our motor 1 motor 1. And similarly, when the reverse button is toggled, it would be energizing the HMI jog reverse output. In this, we have placed the stop button. Whenever the stop button is triggered, it would initially cut off the motor's movement. And also the similar working with the laser sensor and limit switch. Whenever the laser sensor is being cut, it would stop all the movement of the motor. And also it works with the same as a limit switch, for the limit switch. And similarly, each and every motor have their own stepper enable, so that it can send the values according to which the motor forward or reverse we are toggling. This is for motor 3 and this is for motor 4. And finally, we have placed the sensor to trigger the LED. It will be shown in our HMI, so that whenever the photoelectric sensor is cut, the sensor will be triggered and be displayed in our HMI screen.
My name is Thakur. I am going to explain you the working of automated library shelving system. So we have implemented complex logics, and through complex logics we set output signal. Those output signals get converted into electric pulses to the driver, and this stepper motor controller driver will send the signals to the stepper motors, and that's how we control each and every library shelves. So let me show you by controlling the shelf 4. So we are moving the library shelf 4 as per our requirement, and we have provided this stop switch. If we want to stop the individual library shelf, we can stop it with that switch. And let's take a scenario where we have to go in between shelf 3 and shelf 4. So we will create a sufficient space so that we can go in between them. So we will create the sufficient space, and during this period, if in case library shelf reaches its limit, the limit switch get triggered, and it will stop the shelf by colliding to the wall. And at the same time, if library shelves are operating and if someone enters, the photoelectric sensor gets triggered, and it would stop the entire system. And this is the working of our entire automated shelving system.